So now that we have the free body diagram and the shear diagram, the last thing we need to do is create the moment diagram. The moment diagram is directly connected to the shear diagram and is a sum of the area under the shear diagram up to that point. And so we always start from the left. And so at the very beginning at 0, there's no area accumulated yet. But as soon as we start moving towards the right, any point along the moment diagram is just going to be the cumulative area up to that point. So if we would look at 1 foot in along the beam, the moment would just be this area here. All right, the shape of the moment diagram is going to be slightly curved. I'm not going to have you responsible for identifying exactly where that curve lies. Let's find the points of interest along it. So this point here, if we want to figure out where this point lies, we could do that pretty easily by figuring out the whole area up to that point. And so if you look at this, it is a rectangle and a triangle, and we know kind of where those two parts are. So if we label this top part, let's label that as area A, and we'll label this lower part as area B. And let's solve for those, and that will tell us where that point is on the moment diagram. So area A is just going to be this 600 feet drop. All right, we identified that as a 600-foot drop times the number of feet at the bottom, and then divided by 2 because it is a rectangle. All right, area A equals 1/2 base times height. So our base is 3 feet. Our height is 600 pounds. And then divided by 2 because it's a triangle, divided by 2. And so that will equal, let's see, 900 foot-pounds. Area B is going to be just this rectangle here. So base times height, 750 is the height, and 3 feet is the base. So just 3 feet times 750 pounds, and that is going to be 3 times 750, 2250 foot-pounds. And we add those together, and for area A plus B, it will be 3150. All right, so that is going down as these are lined up here at the 3 feet mark. 3150 is going to be, if that's 3,000, it'll just be right about here. All right, so our first part here is going to have a bit of a curve to it, but come up to that point there. So what we're looking for in a moment diagram is the maximum, and we can tell based on our shear diagram that we haven't reached the maximum yet. So the maximum is actually going to be where the shear diagram crosses the 0 line. That is when we've added up all of the positive area, and then anything after that, represented on the moment diagram, we're going to be adding on area that's in the negative range, and so we know it's going to be descending after this point. So this point here is actually going to be our maximum moment. So in order to find the maximum moment, we need to find where that actual point is. So if we ended up at 250 pounds here, after the point load dropped us by 500 on our shear diagram, then we're going to continue descending by 200 pounds per foot. So how many 200 pounds per foot do we need to descend before we hit the 0 line. And so the way that we work that out is this distance here is going to be 250 pounds divided by 200 pounds per foot. All right, so that's the distributed load amount, and that's where we're starting. And so the number of feet that we need to continue along before we hit 0 is just going to be 250 pounds divided by the distributed load. And so in this case, that will be 1.25, which added on to 3 is going to bring us to 4.25. So this point here is 4.25 feet. That is going to be our 0 on the shear, which corresponds to our maximum moment. All right, so to find the maximum moment, we then need to add this additional little piece of area here. So we figured out A and B, we've added those together. Our maximum moment is also going to involve the area of C. So let's do that in this little space we have here. Area C is going to be equal to base times height divided by 2. So it's going to be the base of 1.25 feet times the height of 250 pounds divided by 2 because it's a triangle. And so that will be 1.25 times 250 divided by 2 is 156.25. And so we are now going to add the area of A and B to the area of C, and that will give us our actual maximum moment. So 156.25 plus 3150 equals 3306. So based on how we have stuff laid out here, that'll be like right out there, and that is our maximum moment. And then the rest of it, it'll curve down. And if you want to find any points along there, it's actually not too difficult to do. You'll just continue to solve for the cumulative area under the curve, and but you'll be adding negative sections going forward. And so that is your moment diagram, and your maximum moment is identified as it corresponds with the 0 on the shear diagram, and it is the addition of all of the area prior to that 0. And so in this case, it is 3306.25 foot-pounds.